Hi guys, welcome back here at the C Engineering Tutorial. So this time is continue lang natin yung discussion natin sa water flow measurement. So but this time sa pipes naman. Okay? Okay, so ito yung ginagamit natin na pang-measure ng discharge, the venturimeter or the venturi tube, no? So it is a convergent divergent tube. So makikita mo man dito, no? So ito yung tinatawag natin na venturi, no? Meron siyang convergent to diverging. Converging, diverging, no? So that is venturi tube. So which has been used extensively for measuring the flow in the pipelines of the diameter ranging from a few centimeters to several meters, but it has been used only to a limited extent for irrigation water. Okay, so the venturi meter consists of three parts. We have this short converging part, then we have a throat, and we have a diverging part. Okay. So it works on the Bernoulli's principle. So we have the pressure head plus the velocity head plus the elevation head is equal at point 1, and then we have the same energy equation at point 2. No? So since yung Z1 natin is equal to Z2, so bali makikita natin na yung difference ng velocity head is equal lang ng difference ng pressure head. No? Now we apply for the equation of continuity at both points. So say yung Q1 equals Q2. So bali yung mangyayari dito is we have, this must be V2, no? Sorry for that. V2 ngayon is D1 squared V1 over D2 squared. So where yung D1 tsaka D2, these are the diameters at point 1 ng pipe at tsaka at point 2 which is yung sa throat na part respectively. So we have also beta which is D1 over D2, no? So like we express, bali gusto natin ma-express yung equation na to in function of beta. So now, substitute natin yan sa flow rate natin na equation. We have area 2 that is square root of 2P1 minus P2 over this density 1 minus beta raised to the power of 4. So to account for the friction losses, a coefficient of discharge is introduced in the above equation. The final equation becomes CD multiplied by the theoretical equation. So it depends upon the type of flow, the type of fluid, and the dimension of the venturi tube and pipe. Okay, so ito yung ginagamit natin na formula for venturi. Like, just plug and play, no? Ganun lang yun. So, given below are the formula to calculate the value of the head difference in terms of the liquid flowing through the venturi from the head difference observed in the manometry tube, no? So, bali, itong H, makasolve natin to using these two formulas also, no? So, depende yan kung yung manometric liquid is heavier than the liquid flowing through the pipe, no? So, pag ganun, yung value ng H natin is just X multiplied by SH over SO minus 1. Pero pag yung manometric liquid natin is mas magaan compared dun sa liquid na nag-pass through sa pipe natin, ito naman yung magiging formula natin. So, like, nag-swap lang yung dalawa, no? So, bali yung H dito na makikita natin, that is the head difference in terms of the liquid flowing in the pipe, while yung X natin is ito yung head difference in the manometer. And then, yung SH is the specific gravity of the liquid flowing in the pipe, and then yung SO, yan yung specific gravity of the manometric liquid. Okay? Okay, so let's have an example. Horizontal venturimeter with inlet and throat diameters 36 cm and 18 cm respectively is used to measure the flow of water. So the reading of the differential manometer connected to the inlet and the throat is 15 cm of mercury. No? So determine the rate of flow. Take CD equal to 0.98. So bali ito yung mga given natin. No? Given yung diameter ng inlet at yung throat natin which is 36 cm and 18 cm. Therefore, makukuha natin yung area 2, no? We have 254.47 square cm. We can also get the ratio ng dalawang diameter which is 0.5. And using this formula kanina, for the actual discharge, and then simplify that one. And we have also H which is 15. This is given. Given din yung specific gravity ng mercury divided by the specific gravity ng water, minus 1. So we have 189 cm of water. So we can now calculate for the 2GH, no? Which is 370,818 cm. We just need to substitute that one dito sa equation natin. Kasi yung 2GH is also equivalent nung 2P1 minus P2 divided by the density, no? So like, ito na yung mangyayari. So we have 0.98 times 254.47 times square root of 370,818 all over 1 minus 0.54. So bali yung actual discharge dito sa venturimeter natin is 0.157 cubic meter per second. Like, formula base. So we have also Python tube now. So it is a device used to measure the fluid flow velocity at any point in a pipe or a channel. It is the simplest form. In its simplest form, the Python tube consists of a glass tube bent at right angles. So ito na yun, no? So we have stagnation point, stagnation pressure, and we have this static pressure. Yan lang. So anyway, may formula din tayo dito. So again, it works on Bernoulli's principle, such as shown here. So bottom line is we have V1, which is CV square root of 2GH. Where yung H, yan yung height to which the liquid rises above the pipe. So nakikita natin dito. And yung CV, yan yung coefficient ng Python tube. So example, we have this static tube placed in the center of a 325 mm pipeline, has one orifice pointing upstream and another perpendicular to it. So the mean velocity in the pipe is 0.85 of the central velocity. Okay, so mean velocity to. Okay, so find the discharge if yung pressure difference between yung dalawang orifice is 50 mm of the water. So take the coefficient of the Python tube as 0.98. So bali, given yung diameter ng pipe, we have 0.325 meter, and also the difference ng pressure head natin, which is 50 mm. Given din yung coefficient ng velocity, which is 0.98. So we can now get the central velocity, or yung center velocity. No? We have 0.97 meter per second for V1. Multiply it by the CV. So we have 0.825 meter per second. And we can now get the discharge. No? We have this mean velocity, which is 0.825 multiplied by the area, which is pi over 4, 0.3. This must be 0.98 rather. Okay? So, bali yung discharge sa Python tube natin is 0.068 cubic meter per second. So, like, plug and play lang talaga sa formula to. So, we have also orifice meter. So, orifice meter or orifice plate is a device cheaper than a venturimeter employed for measuring the discharge of fluid through a pipe. So, it is also works on same principle with a venturimeter. So, like, makikita mo yan dito. So, yung orifice meter, it consists of a flat circular plate which has a circular sharp edge hole called orifice. So, ito yun, no? Makikita mo yan. So, which is concentric with the pipe. So, the orifice diameter is kept generally 0.5 times the diameter of the pipe, though it may vary from 0.4 to 0.8 times the pipe diameter. So, the fluid on reaching the orifice plate converge to pass through the small hole. So, makikita mo, ito yung orifice plate natin. So, makikita mo nag-converge siya. And then, meron tayo dito tinatawag na vena contracta. So, the point of maximum contraction is called the vena contracta. Beyond the vena contracta, the fluid expands and the velocity and the pressure change once again. So, by measuring the difference in the fluid pressure between the normal pipe section and at that on vena contracta, the volumetric and mass flow rate can be obtained from Bernoulli's equation. So the value of the discharge Q through the pipe is given by the following equation. We have the discharge is equal to the coefficient of the discharge for the orifice meter. And then we have this area of orifice multiplied by the area of pipe at section 1, square root of 2GH, where H is the differential head, over square root of A1 squared minus AO squared. So the coefficient of discharge for the orifice meter is much smaller than that of the Venturi meter. Okay, so let's have an example here. Like an orifice meter with an orifice diameter of 10 cm is inserted in a pipe of diameter of 30 cm diameter. So the pressure gauge fitted upstream and downstream of the orifice meter gives reading of 25.524 Newton per square cm and 19.62 Newton per square cm respectively. So yung coefficient of discharge is given as 0.6 for the pipe. So ano daw yung discharge ng pipe natin? So bali, given yung diameter ng orifice natin which is 10 cm. So therefore, we can get the area of the orifice which is 78.54 square cm. Given din yung diameter ng pipe which is 20 cm. So we can now this must be 30 cm. Apology for that. So we can now get the area of the pipe which is 706.85 square cm. So we have also given pressure which is 25.524 Newton per square cm. So we can now get the pressure head which is 25 meter of water. Similarly, dito sa pressure 2, we have 20 meter of water na pressure head. So bali yung differential head nila is 25 minus 20, that is 5 meter of water or 500 centimeter of water. So given din yung coefficient ng discharge which is 0.6, like we can now use the discharge equation for orifice meter. So we got 20873.62 cubic centimeter per second, or in liters, that is 20.87 liters per second. So it's just plug and play lang din sa formula. Okay, so meron din tayong tinatawag na water meter, no, na ginagamit natin sa pipe. A water meter is a scientific instrument for accurate measurement of quantity of water distributed to the consumer. So there are two basic requirements for accurate operation of the water meter. Number one is the pipe must flow full at all time, and yung rate ng flow must exceed the minimum for the rated range. So meters are calibrated in the factory and field adjustment are usually not required, no? When water meters are installed in open channel, yung flow must be brought through a pipe of known cross-sectional area. So meron tayong tatlong basic type ng water meter. We have this low pressure line water meter. So usually they are used in underground pipeline water distribution system. Meron din tayong tinatawag na open flow meters, which is used to measure the flow in open channels or gravity flow in closed conduit system. And we have also the vertical flow meter, which are used to measure flow in vertical pipes. Okay. So let's see what's inside dito sa water meter natin, no? So yan yung makikita natin inside. And yan din yung principle na makikita natin, no? Kinukuha natin yung discharge niya. So yan, no? Wala siyang sound. Ayan, no? Parang may ano dito, turbine din. So yan yung water meter natin. Another 3D video para mas maintindihan natin yung water meter.
Под силой потока вращается крыльчатка. На этой крыльчатке сверху установлен магнит. Вращение этого магнита передается на другой ведомый магнит, установленный уже в счетном механизме. Соединенный с системой шестеренок, которые обеспечивают перевод числа оборотов крыльчатки в использованный объем водоресурса. Измерительная камера герметично отделена от счетного механизма, немагнитной пластиной, прочно зафиксированной прижимной гайкой, через резиновое уплотнение. Счетный механизм оборудован системой шестеренок, через которую вращение от магнита передается на счетные ролики, регистрирующие проходящий объем воды в метрах кубических. На каждом ролике расположен зубчик, и когда ролик делает целый оборот, он на одно деление проворачивает следующий ролик, и так далее по цепочке. Так происходит подсчет использованной воды.
PRM filtration. Today we're going to be talking about the multi-jet PRM water meters and about how they work and how to read them. So when you are looking at the measurement, when you're reading your meter, you have to look at the dials as well as the counter. So the counter is every 100 gallons. So this particular meter, this 1-inch meter, the max flow on that is 50 gallons per minute. So your counter is not going to be spinning all the time. And so just because your counter is not spinning does not mean the meter is not working. As the water comes through this meter, it begins to spin these dials, and each dial will move the next dial up until it is moved to the counter. So this is 10 gallons. This is every 1 gallon. This is every 1/10 of a gallon. And this is every 100th of a gallon. So when this is spinning, when you are reading this meter, you're going to look at the counter, but you also want to look at each of the dial to give you an accurate picture of the amount of water that has run through your meter. For example, this meter has not run any 100 gallons through it, but has run 43.88 gallons through it. So that's on the 4, the 3, the 8, and the 8. And as this continues to go, it will churn, each of these will spin, and it will eventually churn this counter. This is a relatively simple design. It has an arrow on the side, which is pointing in the flow, the direction of water. So you want to make sure that when this is installed, that the water is flowing in the direction of the arrow. Otherwise, it's going to read incorrectly. Is screwed in, holding with this ring holding it in. This is the internal strainer that keeps debris and dirt away from the inner workings of the meter. And that can come off right there. This is a relatively simple design. Basically, there's a paddle wheel in here that spins when the water is flowing through it, and that in turn turns the dials and measures the amount of water that is going through your water meter. With PRM filtration, today we're going to be talking about the multi-jet PRM water meters and about how they
Okay, so we have also propeller meters. So propeller meters, these are mechanical meters, are commercial flow measuring device used at the ends of the pipe and in conduits, flowing full and under pressure. So propeller meters uses multiple blades made of rubber, plastic, or metal, and the main parts of the flow meter consist of the propeller. Makikita natin dito sa A, mounted in a short section of a pipe and geared to a revolution counter. B, which records the rate of the flow and the cumulative total. So water flow measurement in pipes. Flow meter measures velocity of a flow by the water turning the propeller as it passes by, and the area is determined from the size of the pipe. The dial of the meter then reads directly in volume, cubic meter, gallons, liter, etc. And the rate of flow in liters per second is then obtained by simply noting the rate of flow on the dial for any given length of time as measured by a watch. So the meters are available for a range of pipe diameters from 5 to 183 centimeter, and they are normally designed for water flow velocity up to 5.18 meters per second. Propeller meters should be selected to operate near the middle of their design discharge range, and this equipment can be a problem in existing irrigation system with oversized pipe relative to the delivery needs. So section of the oversized pipe may need to be replaced with smaller pipes to provide enough velocity and approach pipeline length pipeline length to allow development of velocity profiles, and propellers are designed to pass to some degree of weeds, moss, and other debris. Only a limited amount of foreign materials that can be tolerated in the flow. So even moderate amounts of floating moss weeds can foul a propeller unless it is protected by screen. Okay, so in the next video, we'll be discussing more on weirs. Okay, so another measuring structures used for water measurement. It could be weirs. Okay, so keep on watching and see you in the next video.